Okay, so welcome back guys to this section. Let's get into the real work. So with what we've done so far, there's nothing working, but this is going to be the first part of our logic. In this section, what we'll be doing is making sure that when we run this, let me run the simulator through my web browser. So when we run this, what we want is, if I'm moving my mouse around the player like this, pointing at anything, this player with this gun, they need to face wherever I'm facing, wherever my mouse is pointing to. And that's what we'll be doing. So we already created a script for this. The name of the script is movement. Remember, movement is attached to the soldier. So if we come check, we'll see that the movement script is attached to the soldier. So whatever we write in movement is basically going to be directly running for this soldier node. So in this case, what we need to do is pretty straightforward. We need to first of all set up a listener, an event listener that's going to be noticing where the mouse movement is. So now in this case, to do that, we'll come inside our onload method here that's commented. So the onload method is used when we want to run some code as the game is loading, as the scene is loading. So in this case, when the scene is loading, we need to make sure that we start the event listener. Okay, I'll be using this on-screen keyboard from time to time, but yeah. So to create an event listener for the mouse, what we do is pretty straightforward. So we'll say this dot node. This dot node refers to this guy here, the soldier. This soldier node. You can see this is the node tree. So this soldier. But what we want is actually the listener to be on the canvas. Basically, this whole section. As long as the mouse is moving inside this whole section, then we need to pick up and see where it is. So in this case, we want to target the canvas. So in this case, we'll say this dot node to mean the soldier, and then we'll say the soldier's parent, which is in this case the canvas. So we shall say this dot node dot parent. At this point, you are now talking not about the soldier, but about the canvas. I hope that makes sense. If you've got more questions there, you can mention that in the comments. I'll address them. But yes, this dot node, the soldier, that's the node the script is attached to. But what we want is this node's parent, which is the canvas. Why do we want the canvas? Because the mouse will be tracking the mouse movement in this area. So this is the one we want to track. So that's the one we'll switch this on for. So this dot nodes dot on, and then inside here we'll have to declare a simple mouse move, which is just one type of event listener. Then the function that we want to run, okay, we can call this anything. So I'll call the function position maybe XY, and then we'll say this. Then on top here, we'll create the function position XY. Okay, so because it's an event listener, it's going to pass in this event argument. So there's a couple of things that will have to happen in this case. So first up, we want to track the player's position. So for this to work, what we need to do is basically, so let me, before we write the code any further, so what we're trying to achieve is, where's my rotation? Okay, so here's my rotation. So what we're trying to do is, let's say if the mouse is over here, this would mean the player has rotated, right? So in this case, we are going to be playing with the rotation. Oh my God, that's supposed to be for the soldier. So I'm going to be playing with the soldier's rotation. So let's say if it's at 45, the soldier is facing there, right? So depending on where the mouse is, we'll be setting that rotation, depending on where the mouse is. So if my mouse is here, the rotation needs to be 85. Okay, if my mouse is somewhere here, let's see, this is probably going to be around 160. Okay, so if the mouse is somewhere here, yeah. So if I'm trying to shoot over on this side, you can try maybe 300. Okay, so the idea is wherever I am looking, this script is supposed to calculate the angle. Okay, it's going to calculate the angle, in this case the rotation, and then we set the rotation on the player so that he faces that thing. So now for that to happen, we need two things. One, we need the player position, and then two, we need the mouse position. Then we can create an angle between the two of them. So in this case, this is easier illustrated with this function. This is the actual atturn2 function that we'll be using in the tutorial. So in this case, this is the player over here, and then this is the mouse position over there. And then what we'll be doing is basically calculating the angle from the player to the mouse position. Then that angle is the one that's going to be used on the rotation for the player to face that direction. So that's basically what's going on. We'll be playing with the rotation based on the angle between the player and the mouse position. Okay, so we'll proceed with the coding. So first up, we'll get the position of the player. So just create a simple variable, and here I am using my JavaScript again. So our player position. So the player position is going to be a vec2. So that's going to be a vec2 v2, and then inside there we'll get the nodes x and y coordinates. So in this case, we'll say this dot node, which refers to the player, dot position dot x, and then we'll say this dot node dot position dot y. That's enough. Okay, so let's say here I've got an error. Okay, so cc.vec2. Okay, so we get the node's position on the x-axis and on the y-axis. Just so you don't understand what I'm talking about, the soldier has a position, and in this case, this is the position. Maybe I'll also put it exactly on the center. So the positions player on the x-axis and on the y-axis. So we get these values, and then we store them in this vec2 object. So after doing that, next up what we need to do is get the position of the mouse. So our mouse position, this is going to be event.get location. I can see my code highlighting my code suggestions. So event.get location is being passed from this argument there. Every time the mouse moves, we get the location. So then we'll go on and convert this mouse position to something that is of the game world. So in this case, this mouse position has to be in these units that are in the canvas, these units that are in the game scene. So we need to do that conversion. So in this case, we'll say mouse position is equal to this dot node dot parent, okay, the canvas. Then we'll say convert to node space AR, convert to node space AR, okay. Then that's going to do the conversion. So we'll pass in the mouse position as what's being converted. Okay, so after doing that, let me just show you what this looks like right now. So we'll print to the screen mouse position every time we move our mouse. So let me just run it and then come to my console over here. So we'll run it from the simulator. Okay, so just take a look at what's going to be happening. Every time I move my mouse inside here, this section will be updated. Okay, so maybe this is not the best way to show it. I'll use the browser's log. So in this case, I'll just open the
rotate debug mode.
I'll just open my developer tools just so that I show you how. Yes, so in this case, every time I'm moving my mouse around, you can see in this bottom section, we are having the X position of the mouse and the Y position of the mouse, all right, and they are converted to these numbers that we can work with. So every time I move my mouse, if it's not moving, then nothing happens, but if it's moving, so that's what we are doing so far. So now that we have the mouse position, all we need to do is calculate the angle between the mouse and the player. So we'll create a new variable var angle, and this angle is going to be from the mouse position, wherever the mouse position is, all the way to the player. So in this case, var angle is equal to mouse position dot sine angle okay, then in this case, player position. So this is going to be creating basically, this is what is basically going to work like our @2 function, in the sense from the mouse position to the player position, we get an angle. From the mouse position to the player position, we get an angle. So in this case, that's what we need to do. I will just log this also, just so that you see okay, so before I show the output of this, I'll just make sure that this is set to any number but 0. So the sine angle function has issues with 0. So this time when I run it, you'll see that it should be able to give me the angles in radians. So when I move the mouse around, it's basically going to be showing me the radians. Okay, so the only problem is that this rotation here is in degrees, this output is in radians. So what we need to do is then convert these radians to degrees and then set the player's rotation or angle to the angle that has been calculated. So far, that's the only challenge remaining. So in this case, we'll get rid of that. We can see that we are able to get an angle even though this angle is in radians. So proceed to change to degrees. So I'll say var look angle, or maybe I'll just say angle degrees. So angle D sounds like angle D, but in this case angle D. So angle D will be equal to, Cocos has got a number of functions. One of them is the radians to degrees. So radians to degrees. So whatever radians I pass in there, in this case angle, will be converted to degrees. So in this case, angle has the angle in radians, then angle D will be the angle in degrees. Then all we would have to do is basically set the node to have that angle. So this dot node dot angle, this is the same as this dot node dot rotation. It's just that rotation is outdated. When we use rotation, Cocos Creator is going to complain. So it's better to use the more recent one, angle. So this dot node dot angle will be equal to angle D. So that's basically what we've done. So normally there's an issue in terms of the actual mapping. So let me just see if I can demonstrate that. So when we run it, okay, right now you'll see that it's inverse. It's going in the opposite direction. Okay, we've set the angle, but it's going in the opposite direction. So to make it move in the correct direction, we need to multiply it by a negative number. So in this case, we'll multiply it by -1. I'll close that. So in this case, we'll multiply it by -1. This will be angle D is equal to, this will be equal to angle D times -1. Okay, that's going to be fine. There's still one more issue that will not be solved, but for now you'll see that that's going to be, at least it's now not going in the opposite direction. Now you can see that maybe it's not clear on that view. Let me open it on the browser. So you'll see that it's not quite exactly pointing. So the player is not exactly pointing. So this player is not pointing at exactly where the mouse is. So it's normally always off by about 45 degrees. So what I normally do is I'll then add plus 45. Okay, I've seen in some cases, especially people who work with Unity and others, it will be at 90 degrees. So you just adjust according to how far off yours is. So I'll recompile after adding that, and then I'll click on it. And then okay, so 90 degrees is way too much. Okay, so in this case, 45 degrees is supposed to be minus. Okay, so instead of plus. Okay, so now it's pointing where the mouse is. Okay, as long as I'm in this white space, it's going to point at where the mouse is. Okay, so that's what this line here is doing. We multiply by -1 so that it's not going in the opposite direction. Then we subtract -45 degrees, just so that we accommodate for that section where it's being off by about 45 degrees. Then we include the node's angle to be the angle that has been calculated, and that's all that we've done. So we'll end here in this section. Again, if this has been helpful, throw a like, subscribe, ring the bell icon, and if you want to support me further, of course, look at my online courses. If you want to create an endless shooter, an endless runner, or even a space shooter type of game, or you just want to go through the Cocos Creator basics, I've got courses for that as well. Leave a comment if you didn't understand any section. I know this is not perhaps the easiest code for beginners, but stick around and let's talk in the comment area.